Hello! I am going to start something new today. I have been promising for some time that I was going to make some circuit build or simulation videos and make those available to my $2 and above patrons as an incentive for people to become $2 a month patrons rather than $1 a month. First of all, nothing against my $1 a month donors. I get about 30% of my support, $1 a month at a time, so thank you very much. But when you donate $2 a month, I actually get a higher percentage of what you donate. So as an incentive for some of you to add that extra $1 a month, I have decided to make these build videos available to you. However, very few of my patrons are taking advantage of the one-day preview of my videos. And still a big thank you for your support. And obviously you are supporting me because you think I'm doing something great, but just aren't taking advantage of the one-day preview. So if I have a very small number of people watching these build videos, I'm going to just treat them like a regular video, do a one-day preview, then make them public. However, if I get a large number of people paying $2 a month for the privilege of seeing these videos, then I'll continue to make them exclusive to my $2 a month and above patrons. So let's get started. As you can see, I'm at the FAL Circuit Simulator at falstad.com/circuit. And I'm very new to this, but I like this simulator. It has a lot of visuals. It's a little tricky to use so far, but it has great visuals. And one reason I found it is because it has a tunnel diode available, and I was able to use it for my tunnel diode oscillator videos. So be sure to follow along. You can go to falstad.com/circuit and get to exactly where I am. You can also download this and use it locally on your computer, but it's online, and so you can use it either way. So here we are. First thing I'm going to do is make this full screen. So let's go over to File and drop down to Toggle Full Screen, and there we are. This gives us a little more room to work with too. And what I want to do today is build an op-amp-based relaxation oscillator and then modify it to have a variable duty cycle. And I've done a little experimenting already, and I could build the circuit from scratch, but the circuit's already available. There are a lot of circuits already available here. So let's go up to circuits. You can see I'm up there at the menu on circuits. I'm going to click that and go down to op amps, slide over to op amp, and we go down and there we go, oscillators, and right there, relaxation oscillator, and click it, and there's our circuit ready to go. So all I have to do is modify this to have a variable duty cycle. So let's look down at the bottom here. We have our two scopes, and as I slide around, you can get this cursor, which shows us information over to the right. But over here shows us the green line is our voltage across our capacitor right there. And I really haven't figured out what this yellow line is yet. It is not the voltage between these two resistors, because as you can see over to the right, if you look over here, you can see that it just stays at either plus 7.5 volts or minus 7.5 volts. So it's not doing anything like we see over here. So, but anyway, here's the voltage across the capacitor, the green line, and here's the output voltage over here. So we have a square wave coming out now. So what I want to do is modify this so I can change the voltage at the ground point over here that I am trying to highlight and get a variable duty cycle. The first thing I need to do is get to the supply voltage, and it's not here. So what can I do? Let me do a little jump cut here and do some figuring out, and then we'll see what I found and see where we can go from there. Okay, what I found is I can right click on the op amp and click edit, and it shows me a maximum and minimum output voltage. This appears to be my supply voltages, and so it has plus 15 and minus 15 volts. So what I need to do is build myself a plus and minus 15 supply and tie that to the ground so that I can use that. as if I was tapping directly into this. So what I'm going to do now is build a plus and minus 15 volt supply and tap into that. So let's go ahead and hit cancel here. And I'm kind of new at this, so I may stumble around a bit, but let's see what we can do. I'm going to go up here to draw and add resistor, inputs and sources. Okay, there we go down. Voltage source to terminal. Okay, I'm going to click that, and I've experimented around, and I found if I want my positive at the top, I need to click and drag upwards, and there is one battery right there. And now I want another one here, so I'm going to click and drag upwards again, and there's another battery. And as we saw here, I right click, click edit. We see this is plus and minus 15 volts, so I hit cancel. So I'm going to right click here and edit, and it says it's 5 volts. I'm going to make that 15 volts. And same here, right click, edit, and 15 volts. So I'm just typing 15 and pressing enter. So now I have my two 15 volt batteries. Unfortunately, it's not labeling it here. I don't know if I can label it or not. Let's see what we can find out. Nothing under the edit option. Well, we'll deal with that later. We just know that these are each 15 volts. Now I just need to tie them together. So I'm clicking draw, add wire, and we'll tie these together. And now I'm going to click draw, and let's see, passive components. Like I said, I'm going to stumble around here a bit. I need to add a ground. So inputs and sources, where? There we go, right there, add ground. So I'm going to put a ground right there. So I'm clicking and dragging downwards. I want to move this to the right a little bit. I'm getting too far to the left. So I'm going to click draw, and where'd it go? Where'd it go? Drag. And I have an option to drag all. So I'm going to drag all to the right. There we go. Okay, now I want to add a wire. So draw, add wire, and I want to put that between my two voltage sources. So now I have a ground tied to these grounds, and I have 15 volts here and 15 volts there. So there's my plus 15 and my minus 15. Of course, the op-amp already has its own power supply, so this is just in parallel to it. But I can treat it the same as if it is the supply supplying the whole circuit. So what I want to do now is put a variable resistor right about here. So let's click on draw, add resistor, passive components. There should be, there we go, potentiometer, add potentiometer, and I want to put that right about there. There we go. It looks like if I move my cursor around, I can make it, the arrow go either to the right side or to the left side, but I want it right there. Now let's put some wires in. Click draw, add wire, and I'm going to click and drag over to here, then click and drag over to there. Same thing down here, click and drag, then click and drag, then click and drag. Did it a little differently, but you see what I ended up with. Now I need to get rid of these two grounds. Easy enough, right click on them and click on delete. Right click and click on delete. As you can see, the circuit has stopped working. Nothing going on over here, nothing going on over here. But now I'm going to tie what used to be the ground over to this potentiometer. So click draw, add wire, click, click and drag, click and drag, click and drag, and with any luck, the circuit will start working again. Let's see what's going on here. Yes. Okay, it is working again. I'm going to speed this up a little bit. It's going pretty slow, so I'm going over to the right here. Look where my cursor is. And I'm just going to speed up my simulation. Speed it up just a little bit. A little less, a little more. That's about right. Okay, so here we are. It's working again. We have our green line as our capacitor. Here is our output, which is a square wave. Now, if we look over at our potentiometer, we see that looks like it's a 1K potentiometer. I'm going to do a little experimenting here. I'm going to leave it as 1K for now, but we see we have 500 above and 500 below. Let us move our, can I just drag it here? No, but I can do it over here. So over to the right, we have a resistance slider, and I'm going to slide it to the left. Now I'm going to slide it to the right because I want it to go down. So it's going to go down, 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 and I'm going to stop right about there. And let's look at the output. Lo and behold, I now have a shorter duty cycle. Notice it is high, or at plus 7 volts for less time than it is at minus 7 volts. If I drag this a little further to the right, should have an even shorter duty cycle. And let's drag it back to the middle. I want to see something, get it pretty close to the middle. We want to get to 500 ohms. There we are. Let's look at the frequency. It's going to take a second to calculate that. Wait. There we go. It is at 112 point some odd hertz. So let's see what happens to the frequency when we drag that down again. So I'm going over to the slider, drag that way down, have a short duty cycle, and give it a minute to calculate the frequency. Watching right about there. There it is. 83 hertz. So it was 100 and, now I forgot what it was, but it was 100 and something hertz. And when we shortened the duty cycle, it went down to 83 hertz. Now, what I'm predicting is that if I lengthen the duty cycle, I'm going to get the same proportional drop in frequency. So it went down to 83 hertz, where I have that at 123 ohms under 876 ohms. So is there anything I can do to this to make that exact? No, so I had to cancel. So we're about 100 ohms and we're about 83 hertz. We have a short duty cycle. I'm now going to drag that back to the middle to about, let's see, put that at about 500 ohms on each side. Close enough. And wait for it to calculate the frequency. Yeah, it's 111 hertz, so it went down to 83 hertz. Now I'm predicting that if I move this up to lengthen the duty cycle, it's going to drop the frequency the same amount. So let's move it over. Put that about 104 ohms on top over 800 ohms. And notice over here, definitely we did lengthen the duty cycle. So it's at high voltage longer than it's at lower voltage. And it's still calculating. There we go, 79 hertz. So exactly what I predicted. If we are in the middle, if we move our resistance to about the middle, we are going to have our highest frequency. But as we move our resistance either toward the top or to the bottom, thereby changing our duty cycle, we're going to also lower the frequency. So if we move this up, we lengthen the duty cycle. So let's move it up, 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 up. So now we have a longer duty cycle, as you can see down here. And if I move it down, we now have a short duty cycle. So we have a variable duty cycle relaxation oscillator. The only problem is that as we change the duty cycle, we also lower the frequency. I may do some tinkering at some point to see if I can find a way to reduce that change in frequency when I change the duty cycle. But as we see, we have that variable duty cycle if we need it. And I used this as a proof of concept once to design a switching regulator, because we can feed the output back to the input through a filter such that if something causes our voltage to drop, we can lengthen our duty cycle by having that feedback and a filter back over to here. And if the voltage goes up, we can shorten our duty cycle and make a switching regulator. Although this is not the best way to do it, it's a proof of concept of how we can make a switching regulator. So one thing I wanted to do is make a change in the potentiometer. Let's put it back in the middle. I want to get it right smack in the middle this time. There we go, 500 ohms. And let's look at our frequency. Our duty cycle is 50%, 50% high, 50% low. Our frequency is 111 hertz, basically 112 hertz. Now I'm going to increase this resistor by a factor of 10. So I right-clicked on it, click Edit, and just put a little 0 right there and click OK. So now we see we have 5K above, 5K below. And our frequency did not change much. Went down just a bit, went from 111 to 104. So the frequency does not depend largely on that resistor. We changed it by a factor of 10, but only changed our frequency by what, about 3%, 2 or 3%. So that's interesting to know that we can increase the size of this resistor and therefore use less current. Let's make it 100K. See what happens. Edit, make it 100K. 100, hit OK. Give it a few seconds. Looks like we've lowered the frequency considerably. Give it time to calculate it out. And there it is, 80 hertz. Okay, so we lowered it by about a little more than 20% by increasing that by another factor of 10. But of course, we can change our frequency back by changing either this resistor or that capacitor. And of course, our frequency is also dependent on the ratio of these two resistors also. So while we're playing with this, while we decrease that to 80 hertz, let's see if we can increase it back up to around 100 hertz. I should be able to do that most quickly by changing this resistor right here. Let's decrease this resistor by a factor of 10. So it's 10K. Let's make it 1K. Let's see what it does for us. Oh, that really increased the frequency. Give it time to figure it out. And, oh, it said it was 111 hertz. Looks like our scope is a little out of wonk here. So let's put this back at 10K. That puts us back where we were. It said it was 111 hertz, but I don't believe that. That's obviously not. See, we're at 80 hertz now. That's obviously not just 20% more. So it wasn't able to calculate the frequency, and I don't yet know how to. Let me click on the gear here. Let's see. Horizontal scale. Oh, there we go. We can change the scale there. We'll play with that another time. So we'll just put this about where it was before. Click OK. We know we can change the scale if we need to. We'll just leave it as it is now. So there we are back here. Now let's see what happens if we change one of these. Let's go by changing this. Right now we have a voltage divider that is giving us half the voltage here as we have here. So that should be 15 volts. So it's going between 15 minus 15, 15 minus 15. So this should be doing 7.5 volts here. Ah, it's not. Why is that not 7.5 volts? Let's think about that for a second. When this was going to ground, this was going between plus and minus 7.5 volts. What changed? Oh, what changed was we put some resistance over here. So now we not only have this voltage divider, but we're going through some more resistors here before we get to the actual ground. And so that raised the voltage at this point. This is no longer ground. That's what that is. It changes as the capacitor charges and discharges. So we have a circuit that's a little more weird in what it does. So it changed our voltage here. So if let's see what happens if I decrease this resistance. So let's try that again. Right click on it, edit. I'm going to change that to 10K. And let's see what happens. It lowered the frequency. So why did it do that? Well, this voltage became higher, so that means that this capacitor has to charge longer to get to the higher trigger voltage, and then that trigger voltage goes to a minus voltage, and so it has to discharge longer to get to that lower, now more minus trigger voltage, and so that causes the frequency to go down. So if we change this to a higher resistor, let's change it to 50K. Now it should go to a higher frequency. As you can see, we can control the frequency by either changing this resistor ratio or changing this resistor or that capacitor, or in the case of this version where we have a variable duty cycle, as we change the duty cycle, we also change the frequency. So there's just a little experiment with the op-amp based relaxation oscillator. So I hope you found this useful and informative. We will see how many people watch it. I'll make it only available to my $2 and above patrons. And if I get a lot of views, meaning that people think this is valuable enough to go to the $2 level to watch it, I will keep these available only to my $2 and above patrons. But if I don't get a lot of traffic, I'm going to assume that you are donating to keep this channel going because you think I am doing something good and you don't need the benefit of the preview that much. And so I will just treat this like a regular video, give a one-day preview, and then make it public, and for the benefit of more. So thanks again for your support. I could not make these videos and keep Vocademy going without it. And thanks to everyone for watching.